This lesson is on the quadratic formula. By the end of this lesson, you should be able to apply the quadratic formula with real solutions to a variety of problems and describe the nature of the roots. We saw in Algebra 1 how any quadratic equation could be solved using the process of completing the square. This is reviewed in exercise 1. So solve the quadratic equation for all values of x by first completing the square on the quadratic expression. Express your answer in simplest radical form. So anytime you have a quadratic and the directions say simplest radical form, you know that means it is not factorable. Also, we know that there is no number that multiplies to be 1 and adds to be -6. But this is our hint that we should have a radical in our answer. So we're going to complete the square. Remember, the letters for completing the square are cab. So first, move your c. So x squared minus 6x equals -1. Remember, ax squared plus bx plus c equals 0. So we moved our -1. Now we have to divide by a. Well, a is 1, so I don't have to divide by a. The next step is to add half of b squared. So half of -6 squared is -3 squared, which is 9. So I'm going to add 9 to both sides. So add 9, add 9. Now I have x squared minus 6x plus 9 equals 8. I'm going to factor this quadratic, which is a perfect square, so it's x and 3. And because I need 3 times 3 is 9, and 3 plus 3 has to be -6, it's a minus, and it's squared, equals 8. Okay, I'm done completing the square, but I haven't solved for x yet. So I need to undo the squared, so I'm going to square root both sides. Therefore, x minus 3 equals plus or minus square root of 8. Then I'm going to add 3 to both sides, so x equals 3 plus or minus square root 8. But I need to simplify that radical. So using my factor button on my calculator, so menu, number, factor. When I factor 8, I get 2 to the third. Remember, it's a square root, so it's 2 squared times 2. The square root of 2 squared, or the square root of 4, is 2 radical 2. So we have 3 plus or minus 2 radical 2. Now, we solved that. This answer is real. It is irrational because of the square root of 2, and they are not equal. So when I do 3 plus 2 radical 2, and then 3 minus 2 radical 2, I get 2 completely different answers. Okay? So that is refreshing our memory about completing the square. So since any quadratic can be rearranged through the process of completing the square, a formula can be developed that will solve for the roots of any quadratic equation. This famous formula, known as the quadratic formula, is shown below. You worked with this as well in Algebra 1. So, the solutions to a quadratic equation, ax squared plus bx plus c equals 0, assuming that a is not equal to 0, because that would give me a 0 there, which means it would not be a quadratic, are given by, and we have this equation. So, a is the number in front of x squared, b is the number in front of x, and c is the constant on the end. So we are going to work through a couple exercises with the quadratic formula. The first one says to use the quadratic shown above to solve number 1. So we have our equation x squared minus 6x plus 1 equals 0. So what is a? A is the number in front of x squared, 1. What is b? B is the number in front of x, negative 6. What is c? C is the constant on the end. It is 1. So x equals negative b, which means the opposite of b, so 6, plus or minus the square root, parenthesis, b squared, so negative 6 in parentheses squared, minus 4 times a times c, all over 2 times 1. So I'm going to work horizontally. So 6 plus or minus, and I'm going to plug in everything that's under the square root, all of this part, I'm going to plug in the calculator, and it's going to give me, it's going to do the orders of operations for me. So I get the square root of 32 over 2. Now, I need, again, simplest radical form. So I need to break down my radical 32. So when I do that using my prime factorization on my calculator, I get 2 to the 5th. Well, 2 to the 5th means I have 2 squared, and 2. So 2 times 2, that gives me 6 plus or minus 4 radical 2 over 2. And I have to divide each term by 2. So 6 over 2 is 3, plus or minus 4 over 2 is 2. I cannot divide those two, so since this went into this evenly, that's all I have to do. And I get radical 2. So x equals 3 plus or minus 2 radical 2. And I already know that is a real answer. It is irrational because of the radical 2, and they are not equal. So that's how I describe the roots. And it matches what I got in exercise 1, just 2 different forms, completing the square or the quadratic formula. 2 different ways to solve the same quadratic that is not factorable. You could also use completing the square and the quadratic formula if it is factorable. So exercise 3. Which of the following represents the solutions to the equation x squared minus 10x plus 20 equals 0? So I look at the answers. None of the answers are real and rational. So I know I have to use either completing the square or the quadratic formula. Since this worksheet and this lesson is all about the quadratic formula, that's what I'm going to use. So a equals 1, b equals negative 10, and c equals 20. So x equals negative b, well the opposite of negative 10 is 10, plus or minus the square root, parenthesis, negative 10 squared, minus 4 times a times c, all over 2 times a, which is 2. I'm going to plug in what's under the radical in the calculator, and I get 20. So x equals 10 plus or minus the square root of 20 divided by 2. I need to simplify my radical, so when I prime factor 20, I get 2 squared times 5. So I have 10 plus or minus, so x equals 10 plus or minus 2 squared is 4, the square root of 4 is 2, square root of 5 divided by 2, and I have to divide each term. Now I get 5 plus or minus the square root of 5. So again, my answer is real, irrational, and not equal. What makes that irrational and not equal? This number under the radical, 5. Okay? All right. So let's talk about how you can check your answers in the calculator. So grab your calculator. We're going to get onto a calculator page. If I'm going to store my answer in exercise 3, I can't store both of them at the same time, so I have to do one at a time. So 5 plus the square root of 5, get out, store it for x. So you can see that's an irrational number. Okay. Now I'm going to plug it into the equation, so x squared minus 10x plus 20, and I want it to equal 0. That's a problem. Oh, I forgot the minus sign. Haha, that's what the problem is. Did a times sign instead of a minus sign. There we go. And there's 0. Whew. Now we're going to store the other version. So I'm going to arrow up. And I'm going to use a minus. Hit enter. Now I get its, notice these are called the conjugates. Okay, so the only difference is one's a plus and one's a minus. And I'm going to store and see if it works in this equation again. I should get 0, and I do. So I know my answer to exercise 3 is choice 4. Okay, all right. On to the next bunch. Although the quadratic formula is most helpful when a quadratic expression is prime or not factorable, it can be used as a replacement for the zero product law in cases where the quadratic can be factored, and we talked about this. So solve the quadratic equation shown below in 2 different ways, A by factoring and B by the quadratic formula. So the first one we're going to do by factoring and graphing, and then the second one we'll do by, in part B, we'll do by quadratic formula. So factoring. We have an A value, a B value, and a C value. There's nothing in common, and it's a trinomial. Therefore, that means I have to use AC box. So A times C is negative 12. The negative means my signs are different, so B equals 11. So I need a negative 12 and a positive 1. Make my box. 2x squared. Negative, I had those backwards. Sorry. Hopefully you caught that. This should be a positive 12 and a negative 11. So positive 12x minus 1x is 11x and minus 6. The factors, x, 6, 2x, which makes this a plus, negative 1. So I have x plus 6 times 2x minus 1 equals 0. Set my factors equal to 0. I have x equals 6 and x equals 1/2. Now I'm going to do it graphically. So that means you're going to need to grab your calculator. So when I grab my calculator, I am going to graph 2x squared plus 11x minus 6. I want to make sure I can see the bottom of this since it is a parabola, so I'm going to do negative, 15. Nope, need more. Can't get over there. So how about negative 25? Looks good. I'm going to drag that out of the way. Do my zeros. So menu, analyze graph, zeros. There's 1. Analyze graph, zeros. There's the other. And I can clearly see that something is wrong with my work. Oh, I forgot the negative sign. So I'm going to graph this on my paper. I'm going to label all the parts, including my axes labels. That's one of the most important parts. So the person grading your paper can recreate it. So this is what I have. This is where I made my mistake. There should be a negative 6. 2 calculation mistakes and 1 problem. Bad. Make sure if you solve graphically, you write the answer, x equals negative 6 and x equals 0.5, which is the same as what I got by factoring. So now, let's go and solve by the quadratic formula. So A equals 2, B equals 11, and C equals negative 6. So x equals negative b plus or minus square root b squared minus 4 times a times c, squeezing that in, all over 2a. So x equals negative 11 plus or minus the square root of 169 over 4. Now 169, if I do factor, I get 13 squared, so it's a perfect square. So x equals negative 11 plus or minus 13 over 4. All of this is rational. So I have to do the math. Negative 11 plus 13 is 2 divided by 4. So I get 1/2. Negative 11 minus 13 is negative 24. Divided by 4 is negative 6. These answers are real, rational, and not equal. All because of what was under that radical sign. Okay, so that's how we describe those roots. Our answers, or our roots, are 1/2 and negative 6, which we got 3 different ways. So some of the decisions you have to make is how you're going to solve a quadratic. All right, let's try exercise 5. But notice the quadratic formula is useful in algebra. And it's on your formula card or your formula sheet. So you do not have to memorize it. So we're going to solve each of the following quadratic equations by using the quadratic formula. Some answers will be purely rational numbers and some will involve irrational numbers. So we are going to place all our answers in simplest radical form, if there is a radical. So why don't you pause the video and do A and B, and then we will describe the roots. All right, well, hopefully these are the answers you got for part A and part B. Let's look at the roots and how we're going to describe them. So this is our solution to x, 1/2 plus or minus 1/2 radical 11. Our answer has a radical in it that can't be simplified, so they are real, they are irrational, and they are not equal, because adding 1/2 and subtracting 1/2 is not the same thing. Well, what made this irrational? This thing way back here made that irrational, correct? Because 44 is an irrational number. It caused us to have 2 radical 11. So in part B, my answer is 3. This is called a double root. It occurs twice. And if you think about this question, I can find numbers that multiply to give you 9 and add to give you negative 6, correct? X minus 3 and x minus 3. Therefore, x equals 3 and x equals 3. So if I had solved this by factoring, I would have gotten 3 twice, which is called the double root. Well, in the quadratic formula, I only get 3 once because the square root of 0 is 0. If I add 0 and subtract 0, I get nothing. I still get 0. So I end up with just 6 over 2, which is 3. So if you get a radical 0, then your answer, or you just get one answer, is real, it's rational, and this time they are equal. They are the same. And what caused that? That thing under the radical, the radicand, being a 0. All right, last page of notes. Exercise 6. Consider the quadratic function f of x equals x squared minus 4x minus 36. Algebraically determine this function's x-intercepts using the quadratic formula. Now remember, x-intercepts means y equals 0. So we have 0 equals x squared minus 4x minus 36. They want us to use the quadratic formula, and we are going to get a radical. So a equals 1, b equals negative 4, and c equals negative 36. So x equals negative b, which is 4, plus or minus the square root, negative 4 in parentheses squared, minus 4 times a times c, all over 2a. Since a is 1, we just get 2. So x equals 4 plus or minus, well, we've got to plug that in the calculator, and we get 160 divided by 2. 160 breaks down into 2 to the 5th times 5, so we have 2 squared, 2 squared, 2 times 5. So that means I can bring out two 2's, which is 4 plus or minus 4 radical 10 over 2. So my answer is x equals 4 over 2 is 2 plus or minus 2 radical 10. It says to express the x-intercepts of the quadratic to the nearest hundredth. So I'm going to grab my calculator. And again, I can only put in one at a time. So 2 plus 2 radical 10. So 2 plus 2 radical 10 to the nearest hundredth is 8.32. Now its conjugate, 2 minus 2 radical 10 is negative 4.32. And then it says, using your calculator, sketch a graph of the quadratic on the axes given, use the 0 command, and label everything. So we're going to grab our calculator and graph this quadratic, x squared minus 4x minus 36. Again, I need to change the scale down here. Nope. Looks like I need to go kind of far, so I'm going to do negative 30. Still not enough. I never guessed correct on the first try, so I'm going to do negative 50. I need to find these zeros, so menu, analyze graph, 0, menu, analyze graph, 0. And then I need to get this onto my calculator. I should have changed the scale in here to match the one on the paper, so I need to change this to a 50, tab 20, tab negative 50, tab negative 20. Hit enter. So this is what needs to go on my paper, so pause the video and do so. And hopefully your answers look like this on your graph. To describe these, because of this radical 10, or more importantly, the radical 160, our answers are real, irrational, and not equal. And we can clearly see by the graph that those roots are not equal. So in number 7, they want to know which set represents the x-intercepts. So I'm going to use my graph. So I'm going to pull up my calculator again, and I'm going to graph this quadratic. So get a new graph, 3x squared minus 19x plus 6. And I need to find these intercepts. So menu, analyze graph, 0. There's one of them. That looks familiar. Here's another. Excellent. So I have 0.3 repeating, which I know is the same as 1/3, and 6, which is choice 4. I did not have to do any algebra. I could just graph it. All right, pause the video and read exercise number 8. All right, I'm going to give you fair warning, write small. So we have our crazy caramel corn company, and we want it to be at least 50% of the kernels will pop. So we need negative 1 over 250. I'm going to call it an x instead of a t. X squared plus 2.8x minus 394 to be at least. So it needs to be greater than or equal to the percent, so 50. Now we know from our work with quadratic inequalities that we're going to make this into a quadratic equation. And we also know that we do not want to factor this, so we're going to get it equal to 0 and use the quadratic formula. So negative 1 over 250 x squared plus 2.8x minus 444 equals 0. So x equals negative b. So negative 2.8 plus or minus the square root of negative b. So, sorry, not negative b. b squared, so 2.8 squared minus 4 times a times c all over 2 times a. Whew! That was kind of difficult. So now I'm going to definitely use my calculator for this. So x equals negative 2.8 plus or minus square root of something over square root of something. So let's get these numbers. So under the radical, you should have 0.736, and on the bottom, you should have negative 1 over 125. Now, in the question, it said to round all your temperatures to the nearest tenth. So I'm going to use my calculator to plug these in. So here we go. We'll get a calculator page. I'm going to get a fraction. So negative 2.8 plus square root 0.736 over another fraction, negative 1 over 125. So my first temperature, x equals 242.8. Now I'm going to do its conjugate, so I'm just going to click on it and change that plus sign to a minus sign. And I get 457.2. So now what I need to decide is, am I between these or outside of these? So again, like we've learned, these are on a number line. So this is 242.8 and 457.2. These are included. So now I need to decide. So I'm going to pick 3 numbers in the segments. So I'm going to pick 200, I'm going to pick 300, and I'm going to pick 500 to test them. So why don't you pause the video and do that also. So I got true to be in the middle. So I'm going to write my inequality, 242.8 less than or equal to t less than or equal to 457.2. So that was quite a lot of work. I needed a little extra paper for my giant handwriting. Good luck with this. If you have any questions, ask in class.